Hello, good morning to everybody. My name is Francesco Franchini. I'm a technical manager of SPDM and Optimization Competence Center in EnginSoft. The summary of this presentation is on the slide, and we will see a short summary about, we spend a few words about EnginSoft company and the modeFRONTIER introduction, very short slide, and then we will move to the business case that is the topic of this webinar. I invite all of you to make questions using the chat panel, and then if it's possible we will reply online directly, or if not, in any case we will reply offline after the webinar. Okay, just a word about EnginSoft. EnginSoft is one of the leading technology transfer company in the field of simulation-based engineering science. Has been founded in 1984. I suppose most of you likely knows EnginSoft. Today, EnginSoft has grown up and it counts almost 160 experts in new technology and leaders in virtual prototyping, simulation process, and data management, and multidisciplinary optimization. Sorry. We try to help our customer in their innovation path, and we add value by showing company how to use all their existing and new investments in technology simulation to get the best possible results about their product and process challenges, and in order to maximize return on investment and competitive business advantage. These are our 4 pillars. Our revenue is based on these 4 pillars. So software selling, we are channel partner of several software houses, and we provide also specialized training course, more than 200 in our offer. And we provide also consulting activities. We have a great experience with more than 3,000 successful customer projects. And last but not least, we are really active on R&D field with more than 80 R&D co-founded regional and European projects, which cover more or less 10–12% of our global revenue. We are present in Italy, where we have 6 offices, in the United States, in Virginia, and then we have 5 other EnginSoft offices around Europe, in France, United Kingdom, Germany, Turkey, and northern part of Europe in Sweden. But we have also close partnership with synergetic companies located around the world in Portugal, Brazil, Japan, Korea, and so on. These are our main technologies that we distribute. As you can see, the first 2 are ANSYS and modeFRONTIER, which have been used to work out the business case which will be presented today. So I would like just to spend a few words introducing modeFRONTIER. modeFRONTIER is an integration platform with seamless coupling with third-party engineering tool. It means CAE and CAD tool, but also Excel, MATLAB, in-house code, and is a complete solution for process automation and optimization in the engineering design process. I don't want to spend to take more time and to spend more word about technologies, but I want to introduce the next speaker. Next speaker is Francesco Perticaroli. Francesco Perticaroli is a mechanical engineer and is a FE senior analyst at AristonThermo Group. Francesco will present us the business case of today.
Share my screen. Okay. Can you see my screen then?
Yeah.
Yeah. Okay. Excellent. Okay. Thanks, Francesco. And obviously, my name is Francesco. Just to help you to remember the name. So actually, I work for AristonThermo Group. Yeah, in Nosimo, which is in the central parts of Italy, and actually, I'm in charge for the simulation team. I'm the maker simulation team manager. So what I'm going to present to you is the exercise just to perform parametric, just to use a virtual simulation and just to find out the optimal design using parametric analysis by modeFRONTIER. Obviously, all the presentation starts with a couple of slides regarding our company. So AristonThermo Group is a global company. It's spread out around the world. That's the figure about the number of people in the world that use and appreciate our products. And the missions or vision, if you prefer, actually is the sustainable comfort for everyone, just to make the comfort accessible for everyone. It's actually is not just the not just to make comfort to everyone, but make the comfort accessible for everyone and respect the environment. That's the two main points that we are going to follow in this year and the years past. We have 5 different pillars that we drive us in these tackle, or we try to tackle us to make the comfort accessible for everyone and respect the environment. The first one is the aspire through the excellence. Not that it doesn't mean that we need to copy to someone, but that means get the inspiration for excellence in every part of the world. So I'll start, for instance, in one of those. And the other one is to believe in sustainability. Actually, if you want to respect the environment, the first one is to believe in what is the sustainability environment. And the third one, that's really important, actually, we need to start with the customers. So our focus in the customers, what the customer wants, and try to help the customer to make the comfort accessible. And that means customer, that means people, and that merge these 2 pillars together. And finally, so last but not least, proceed with integrity. If you want to respect something, you need to be integrity to be reliable. So actually, there's a couple of figures about that, and I want to spend more time on that slide because it's quite simple to read. That's our turnover, 1.61 billion, and we have roughly 7,000 employees working there around the world. 8 million products and so on, and that's important things, particularly for us, is the 86 million investment in 2018. Okay, that's our brand. It's a part of AristonThermo Group family. Obviously, recently, Colorex is the recent acquisition that Ariston performed. Is it's a really huge company. Roughly, I don't remember precisely, but it should be roughly 1,000 people working there in the center part in America, the Mexico, or remember is the south part of the US. And that's just a simple overview, about numbers of products that Ariston spread out around the world. What I'm going to present to you is the heat pump, particularly the heat pump water heater. So actually, heat pump water heater is just a device to help you to have hot water using the heat pump technology or heat pump thermocycle. And that's to show you an example how to make these products silent and efficient using not only virtual simulation, but virtual simulation in combination with parametric analysis by modeFRONTIER. Why is it important to have the system really silent or to drop off the noise value? Because the vast majority of the time we have a chance to set up this device in the garage, for instance, or in the technical room. But sometimes it's not possible. You can see the picture, and you have the system close to the bedroom, or the living room, or the kitchens, and you have really nasty noise that come out in the living room when you have the dinner. That would be not so good for the customers. That's the reason why you come out with the idea to drop off the level of noise and but in the meantime try to increase the performance of the system. The heat pump, which is just a system, we use a thermocycle approach. So we have expansion valve, compressor, evaporator, and condenser. And in the meantime, we have those two parameters set up at the bottom of the system, and the condenser is just a pipe drop up around the boiler. Condenser is separated with the boiler with hot water for this regulation point of view, but is the chance to have the same effect to the condenser, real condenser in the normal heat pump water heater. So actually, the hot air goes into the system in the inlet part through the evaporators and take it out by the fan. And that's the overview system about heat pump water heater works. So yeah, the challenge is reduce the noise and increase performance. And that's why we come out in combination, in collaboration with EnginSoft. They really help us to perform this activity. Try to define an optimization geometry, particularly the conveyor inlet, to spread out the fluid in the evaporators much more uniform and try to reduce the turbulence and consequently reduce noise. In the meantime, try to increase the performance of the products. Just to describe you in pictures, which are easy to understand. Say, if you go into the system, as you can see here in the, let me just use the, there we go. So the air goes into that system, goes through the evaporators and take it out by the fan. And that's the speed profile out. So you can see here is a really, really unbalanced. And that's it confirmed by the testing. And that means if you have unbalanced behavior, you don't have a chance to work the component's 100% its capabilities. And that means the performance is low, and the chances are that you have really turbulence phenomenon which come out due to the fact that they do not have a complete homogeneous system, and consequently that turbulence can create noise. So actually have two main objectives. Try to increase the performance of the evaporators, just to spread out fluid homogeneous at the inlet of the evaporators, and in the meantime reduce the cause of nasty phenomenon noise, which is turbulence. Actually, we have the necessarily to represent these pictures, really nice color, with a number which help us to find out one solution is better than the others. And we use the standard deviations compared to what would be the daily distributions. Standard deviation help us to have two different indicators. The one is how far we are compared to ideal distribution, and the second one, what would be the spread of the velocity. And we try to find out when we realize that we cannot have a chance to spread out fluid in this configuration, and we need an additional device which will help us to that. Then we come out with the fins system, which is set up into the conveyor inlet. And the number of fins, we notice that when we increase the number of fins, we have a chance to spread out the fluids and the standard velocity fairly drop off. And we reach the number maximum construction numbers possible, construction numbers, which is number 5. More than 5 is not possible for the construction point of view or construction limit. And for that system, we set up the standard deviation value 3.87, which is an enormous reduction compared to the current design or the original design. And the question was, okay, we set up what we thought that would be the best positions, but the question was, is that the maximum one? We cannot drop off the value, or is that the best one you can reach? And that's the reason why we come out with a structured theory analysis and automatic workflow by modeFRONTIER. So actually, the reason is quite simple actually to understand, because if you see the left side of the pictures in the input parameters, we have 10 different inputs and 7 outputs. If you do it manually, and without structured DAE analysis or really strict procedures, you don't have a chance to collect the correct results. modeFRONTIER is possible to drive you in a quite straightforward manner to define the DAE analysis, and in the meantime find out what would be the theoretical best in that design space you have to define before. You think about if you can read the system, actually you can move 10 different, or more than, in that case we use 10 different inputs and 7 outputs and 2 main objectives, no reductions, and in the meantime spread out fluids in the evaporators uniformly. So actually, just to recap here, and we use 10 different inputs, okay, 7 outputs. We use the clip positions to have the chance to modulate the area in automatic manner, and particularly when we have the narrow area, the hazy clip is follow the position of the fins. That means arrow bigger. We have one objective, so minimize delta, and 2 geometrical constraints. So actually, the fins can move independently, and we have just 2 geometrical constraints. We create a sort of script to make optimization mesh easily, and also the depth and rest creation. And we create automatic DOE, and particularly we use, that's really important actually, the response surface method approach, and use genetic methods, genetic algorithm modeFRONTIER to run the virtual simulation. That's really power actually, and that's I can show you the beneficiaries in a couple of slides ahead. So the 2 main objectives: increase efficiency, reduce noise. So one of the beneficiaries that modeFRONTIER has in there, and then can use for this application, is try to find out not only which is the best theoretical point design, but what would be the effect of single variables in the final results. For instance, you can see in the slides the red graph in there, and that means that variable is much more, has more influence compared to the purple one to the final results. So there's more changes, that means bigger changes for the final results, and the other side, big changes, that means small changes for that variable, that means no effect in the final results. And you can see here numbers in the straightforward read how is important having single variables compared to the final results. Okay, that's a simple graph just to find out that all the solution is spread out uniformly in the design space. The main point I think is we have a chance to use a train to server, and we run 8 design in parallel. That could drop off dramatically the numbers or the time for simulation. If you have a chance to run 8 design in parallel, that means huge chance to reduce the time for computational time to collect results. Okay, finally, when we have all that done in terms of spread out the correct design to define the correct design space, we use the response sampling method generation, and we run 10,000 simulations automatically in a few seconds using the response surface method plus modeFRONTIER genetic algorithm. That's really, really important actually, because we have a chance to explore enormous numbers of simulation without carry out physically, just to use this approach to collect an idea about what will be the trend. At the end of it, we come out with the sort of post-processing. You could have just an example in there then, but the main important thing is we have the chance to define the Parametric frontiers, and in there then we come out of the 3 best designs, what we thought was the best 3 designs, and you can see here just a couple of slides, and we run and we collect the setup because they're virtually, and we run in the CFD mode, and we notice that what is virtual was really close in what is in the simulation. When you use virtual, that means design carried out by its response surface method approach. And the result in the CFD simulation you can share here compared to the current design, so the original thin 5 position, that means an enormous homogeneous velocity distribution, and then that's a cross section, high reducing the turbulence, particularly the inlet and the inlet. And the second one is you have a chance to spread out the velocity of the evaporator in a really completely clever manner, much more better than before. And if you want to translate these color pictures in the figure, that means the standard deviation is now 2.61 meters per second. So actually, we started with 4.91. We drop at 3.87, and we after this de-optimization we reduce really high, and we have 2.6. That means really homogeneous compared to the position at the beginning. Yeah, just to summarize, and sorry for this long presentation, but just to summarize the advantages for combination for safety and modeFRONTIER approach. The first one is now this component works roughly 60% to 70% of this capability, and the standard deviation is drop off of 40% roughly, and obviously that means increased efficiency and uniformity for the evaporator flow distributions. The main important things was try to reduce the noise, and we drop off at 3 dB, which is really enormous value, and that's the high performance noise reduction set up these products as a leader in the market for Evaporator, obviously. And this component or this idea is covered by patent. It's really high important. That means for innovations and contribution about simulations and so combination of virtual simulation modeFRONTIER approach. And as the last but not least, it is really important, and the new methodology has been defined for similar analysis. Actually, is just an example, but you have a chance to perform a combination about modeFRONTIER and virtual simulation for all that kind of stuff. You can use the same approach and with the same potentiality and results. So actually, thanks to modeFRONTIER, 10,000 simulation will perform automatically. And the fluid in the conveying inlet, particularly at the beginning of the inlet to the evaporator, is now well distributed. And we have really enormous time reduction when we use modeFRONTIER simulation tool compared to the normal standard procedures. Usually for single time, we have infrastructures, internal infrastructures, we need to spend a couple of days to run single CFD. That means we need to spend 220 days plus to simulation design. So these activities actually has been carried out in 20 days. So it's not comparable in Berlin. So actually, we have advantages in terms of performance, no reduction about these products, and enormous reduction time. Hope you enjoyed that presentation. Thanks a lot for your attention. And if you have any questions, I'm really available for you then.
Okay, thank you very much. Thank you very much, Francesco. Thank you very much for your presentation. I hope all attendees find the presentation interesting. Sorry. And if you have any question, please you can write on the chat panel, and we are available to provide the answer. I would like to highlight again some interesting point about this activity. I think that the first one is that Ariston get a competitive advantage from this parametric analysis. They developed a new competitive product with good performance in terms of efficiency and noise emission. And I think another important point from technical point of view is the use of response surface modeling. So a meta modeling that allow you to speed up, to reduce number of simulation, and to speed up the parametric analysis and optimization loop. The response surface methodology, as Francesco explained, allow you to reduce with enormous reduction of the total number of design that you have to run in the CFD simulation. That is a time-consuming simulation, and you can exploit this meta modeling in order to run thousands of design in few seconds and to get your best results. Other points, last but not least, that you define in this way your process right down in the platform, and you can reuse the process for similar application, just changing model and run again your optimization and automatic optimization.